Good morning. I hope you are doing well. I am doing quite well. It would have been good if I could have had a bit more time on Juggernaut this week, but I had enough, thankfully, to get all of the CAD work done for the next, hopefully the final version of Butler. And I'm very excited to show you what I've done. I have made some pretty, CAD-wise, they weren't too difficult to implement, but I think ease of life for actually interacting with Butler and doing maintenance on it, I think will be much improved from the previous version. Hello, Batboy. It's good to see you. I think this is probably going to be a bit of a shorter stream than usual. I am keen to spend a good bit of today continuing work on Juggernaut, and CAD work is usually a bit easier to show than other stuff. So yes, CAD is done except for the hand, and I think it's going to be easier just to show you the changes that I've made. And of course my Space Mouse decides to pick this moment to stop working. Brilliant. Alright, that is going to be a problem. Yes, Batboy says, those are the best changes, the one that make your life easier. Yes, maybe while I'm trying to get the Space Mouse to reconnect, I actually do have a small update on that side of things, because I've actually taken apart the old version of Butler partially. You can see all of the electronics and stuff is still in here, but yeah, I have taken the lid part off at least, and it wasn't as bad as I was expecting it to be. I did have to feed through the wires through, you hopefully remember that they're, let me show you this. These wires that come out of the slip ring, that this can spin around infinitely, these 4 wires that came through they were routed through this hole in the base here, the bigger one, and then they came up through this. They spurted out through here, then they came up and around, and then they connected onto all of this stuff in here. And that was a little bit fiddly to undo. I had to push the wires back down through here as I was lifting the lid up, and then as soon as I could get it high enough to get my hands in underneath, I could pull them down. And thankfully that worked. That worked without issue, and none of these wires, as far as I'm aware, none of them have broken. I haven't checked the continuity, but none of them ripped out, so that's a good thing. Yeah, and Batboy asks, did you find the problem with the backlash in the yaw stage? Yes, I did. And it was exactly what I thought it was, which I'm pretty happy with that, to be honest. I actually have a video to show you of that. I recorded this morning when I took it apart. And so we can see it is exactly what I thought the problem was. And yeah, which is a good thing, I think. I think this is a fairly easy problem to solve, all things considered. So basically, yeah, the gear that sits on your motor, this guy in here, this is just not grabbing onto the motor properly. And to show why that might be happening, let me grab something. This is the same type of motor that I'm using for the yaw axis, and we can see this shaft that comes out of the motor is fairly small, and the flat part is very small. And the gear that's on there currently, this grey one, is just printed out of PLA, and there's just a hole in the PLA, in the gear, that is the same size as the shaft, and it just sits on there. And I guess at some point I must have overloaded it and it just slipped, and of course as soon as it slips one time, it's just going to keep that. The plastic has then been munged up, deformed, and so now it just slips all the time. So I think the easiest solution for this is to, the easiest solution I think is to just use a grub screw, basically. So I'll have the gear will sit on the same as before, except instead of just having the plastic be the thing that's actually grabbing onto the shaft, I'll have a set screw that comes in from above and lines up nicely. Hopefully that will help. I'm not convinced, that's definitely not going to be the torque output of the motor, especially given that this is a 34-to-1 gear reduction from memory. The output of the motor is going to way exceed the output, the torque delivery of that gear, but that's okay. Yeah, I think it wouldn't be too bad. Yeah, Batboy's saying a metal piece that interacts with the shaft would be really good. Yeah, having the whole gear made out of metal would be ideal, or just an insert that goes inside the gear that interfaces with the shaft but I think a set screw will help. It's definitely not going to be like a final, it's not going to be able to match the torque output of the motor, because as soon as that set screw, like the set screw will still be able to raise up into the gear. It's going to require a bit more deformation than what I used to, what I'd had before, but it's definitely not going to be perfect. Oh, this is so frustrating. I was literally using CAD this morning, all morning, and then as soon as I start the stream, Space Mouse stops. Let me try a different USB port. It's so frustrating because all of this is CAD and I cannot use CAD with keyboard and mouse. But I guess I'm going to have to. All right, we're going the old school way. This is going to be a bit more clunky than usual. I apologize. All right, so yeah, the main changes that I have made to improve on this design are to make the lid a heck of a lot thicker. Maybe I can still use my shortcuts though. Let's see. No, I cannot. Oh, that's so frustrating. All right, is what it is. Yeah, so I've made the lid a heck of a lot thicker because you may remember from the old design that this lid was very thin and the whole thing was like flexing up and it was, yeah, not super solid. It also meant because the lid was so thin, I had to cut out holes in the bottom here to fit in like the main ring part so that it was like as low as I could get it to be. And yeah, those holes were just kind of like growing in size and they were getting a bit too big. So by making the lid a lot thicker, I am able to get rid of those holes entirely. So now if we hide, what is it, Y? I feel like a pleb with no Space Mouse. Yeah, so now there's no holes in the lid at all. It's just completely solid and it's very thick. I think from memory it's 10 mil thick pretty much the whole way through. So it's a beefy boy. Yeah, 10 mil is the minimum thickness. So that's pretty solid now, and I have a lot of confidence that that's going to be a very stiff design. A big motivation in all of this is just to make the whole thing a lot stiffer. I really want to make sure this whole system is like as stiff as possible. So it will always be exactly where we want it to be, and there's going to be as little flex as possible. That is particularly on my mind now. I need to get this out of my way. I keep like reaching for the Space Mouse. Yep, no. Get out of here. Yeah, that is particularly important because of how long the throwing arm is now. So because this is so much longer than it was before, it's like 1.5 times as long as it was before, there's going to be a lot more leverage on the whole thing when it's down, and it's going to want to tip the whole thing up, and it's just going to be putting a lot more bending moments and like weird kind of forces on everything in the system. So I'm really trying to emphasize making this as like strong as I can. Yeah. Yeah, so the lid is a lot thicker, and I've also, I realized, yeah, so I also, because the lid is thicker now, and even despite raising everything else up, I realized that if the pitch axis is in the lowest position that it can be in, it was actually ever so slightly contacting the lid in here. So I've made this little cutout in here, so that way when the pitch axis is as low as it can go, it won't bump into the lid. However, you'll notice that it's actually not contacting right now, and it's actually ever so slightly above. The reason for that is I don't know how this happened, because I checked over everything so carefully so many times, but I think that I changed some things after I had checked everything. So the big concern is that I want to make sure that this black part that tips up and down does not hit into this red part, the main ring, or the thing that's like the bracket that's attaching the main ring onto the lid. And I did that, and it was all hunky-dory, but then I think I must have changed something in this black part, and it was ever so slightly bigger, so now we actually can't go down as far as we could before, but that's like a 1 or 2 degree difference. So right now, the minimum angle that we can get down to is about 10 degrees, is like the lowest angle that we can reach, which is pretty low, and I think that that's going to be low enough for our purposes. But if we do need to eke out another like degree or 2 of low angle, then I can always just I can reprint this black part and just make this middle section a little bit thinner, because that, with the angle limits that I had set before, this in here was contacting the main ring. And this definitely was not like this before, so I don't actually know what I had changed, but this is extremely close between the black part and the red part, and I was very concerned that that might be kind of a bit too close, but I have put it together, and it actually works without issue. So it does tip up and down, and it does hit down the bottom, and at the top, something weird is contacting. I don't really know exactly what, but we still get like pretty much exactly 90 degrees. I think it actually might be pretty spot on 90 degrees. So I'm not that worried about that. And yeah, I don't know if I can get the camera in there to see that, but that in there is very, it's very, very tight. Yeah, you can take my word for it. Yeah, but there's no contacting, and I can't hear any like grinding or anything as it's going along, so it's definitely not contacting, even though it looks in the CAD like it's like, I mean, what does this say? Minimum distance 0.12 millimeters. My goodness. That is definitely the tightest I've ever unintentionally designed something to be. And it doesn't touch, so that's good. What's the shortcut? Yep. Okay, so yeah, the lid that was pretty easy to redesign. And one thing that's worth keeping in mind as well for the way that I have designed this is that, of course, all of this stuff needs to be 3D printed. So a big motivation for making the lid the way that it is that I can print it with this highlighted face being down on the print bed. So all of the other things that are attached onto it are like printed separately and then screwed on. So if I open this up, and of course, as always, there's a link in the description for the latest version of this CAD, so you can check it out and follow along if you so wish. Yeah, so all of this other stuff on the top, like if I hide everything and show just the lid, that's how I printed it. And I've even added these little printability features on the lid so that I don't need to put supports in those screw holes, and that actually turned out quite nicely. I don't know if I'll always do that. It's a bit of a faff to do it, and the support removal is usually not too bad. I just wanted to kind of give this a go, and it did work quite well, so I'm moderately pleased with it. Yeah, but everything else just kind of sits on top. And of course, because everything is raised up now, the whole like pitch axis has been bumped up, I've had to change the way that these bearings are being held as well. And I had a bit of an umming and ahhing about how I can best do this. And what I ended up coming up with is this kind of like two-part solution. So we have like we've got a bracket that goes around the outside and that holds the two bearings in there. And then once the bearings have been put in, there is a lower piece that comes in underneath and just like holds them in. And that works quite well. I haven't actually screwed either of these down yet, so I don't know if that will change anything, but if I'm just like holding this in my hand, like the way that it would be, it is a very, very firm fit on the bearings. And particularly so because I've actually added little grooves. If anyone knows the shortcut for doing a section view, I would love to know, because I'm going to be doing that a lot and I don't know it off by heart. Yeah, I have little grooves cut in. It's kind of hard to see, isn't it? Here we go. I've got grooves cut in this black piece so that when the bearings go in, they are like properly like full on like nestled in there. And that, yeah, it's a very, very solid grasp that this part has. So I'm pretty pleased with that. I think that this whole, again, all of this like motivation is to just make everything as stiff as possible. So we now actually have 6 bearings supporting the pitch axis, and I feel pretty confident that it's going to be very solidly held in place. Yep. All right, cool. So another big thing that I wanted to improve on is that as I mentioned before, when I took apart the old design, I had to feed through these slip ring cables because they were fed through the main ring through this little hole and like up through this channel. It was kind of a faff to lift this lid off if I wanted to get inside into the base. To avoid having to do that in the future, I have improved on this so that now the what is it called? Slip ring cables will now come up, and I will do another section view. So now these cables don't go through the main ring, they just go around it. So now they basically come up through the base here, they come up through this little channel in here, and then up through the back. So if I get rid of the section view, so they basically sneak up through in here, so you can see those cables. They come up around, they come through this hole in the back here, and then they can come up and attach onto this guy. And I'm planning on doing the same thing that I did before, where I'm going to have the 4 screws will go into here. I've already added the what are they called? What are they called? The threaded inserts. That's the one. I've already added the threaded inserts in here, so I'm going to have these are going to be like 4 bus bars. So we'll have like one of these screws will be power, like whatever it is, 24 volts. Another one will be ground, can high, can low, and those will all attach with like little the circle screw, whatever these called, screw terminal things. And that will allow me to very easily add and like to basically change the length of the wires and make sure that all of them are correct, and I can like very easily add and subtract things from that. Yeah. So I think that will work quite well. One thing that I'm kind of annoyed by that I didn't see this until I actually had the thing in my hand, and I should have seen this before when I was doing the CAD, is that like, so the way that the cable is going to go is the same as before, generally speaking, where we have the slip ring cable will come up through here. Let me actually see if I can do this. The slip ring cable will come up, yes, through here, come up around, down through a hole in the top, which I'll show in just a sec, and then out through this hole in here. And yeah, so it's going to come in through this hole up here. And of course, because there's this big channel in here, and I want to make sure that the cable will like sit in that channel when the pitch axis is like completely vertical, it would be great, and it should be the case, that this hole, the channel that the cables come in through, is in line with this channel in the main ring. But I guess I was just being lazy in the moment or something. I don't know. I was not paying enough attention, I suppose. But you can see that that is actually not in the middle. If where's a good... Let's see, Shift X. Ah, thank you, Batboy. My hero. Yeah, if we go in line with this, you can see that it's not centered. It is centered in the middle of this part, like widthways. So if we go like this way, this is centered. But of course that doesn't matter because this thickness is nothing. It should be like here instead. And that's kind of annoying me, and I really wish I had paid more attention to that before. Hopefully that doesn't actually affect the way that the cable will fold and unfold as the pitch axis moves around. Hopefully, if it does, then I'll just have to reprint the part, which is, yeah, a bit frustrating. Yeah. Yeah, so the lid and the main ring were pretty easy to change, I think. Once, there was a little bit of a back and forth to get this to actually be able to go the whole way down without interacting, without like bumping into the main ring. But it looks pretty, it should be pretty solid now. The base, I didn't really change anything on the base, but I have printed it now. That was it printed last night, and I was very afraid for that print because this is a pretty complicated part. There is a lot going on inside this base, and yeah, I really wanted to make sure that it worked. I had this file open in the slicer for like 3 days before I actually committed to printing it while I was printing other things, so I just wanted to be triple checked sure that everything was correct. And I'm pretty confident that everything is correct, and it printed so nicely. I've already attached the ring onto the top because this was a bit flimsy before attaching this ring, but now that the ring is attached, it's very solid. And if I undo the single screw that holds the bottom on, if I can get my driver in there, come on. Just a couple turns of the screw, and now, ta-da, I can open it up. So now, once everything is together, not only can I remove the whole pitch axis much more easily than before because the cables are not being fed through, so I should be able to just remove like 6 screws, and then I can take off the entire pitch axis. Should be pretty good. Not only that, but because the lid will still be on, I won't actually be able to see any of the electronics in here. But now, if I unscrew this from the shelf where it's going to be, I can open it up and get full access to all of the electronics in here. So nice. And I've already glued in the the USB-C to micro USB connector, it's good. I definitely could have made these tolerances a lot smaller. Like all of these gaps around here are way bigger than they need to be, but I just wanted to be sure that this was going to print nicely and yeah, and work. And it does, and I'm so happy. I'm very relieved that that worked. I was very, daunted by that. But yeah, as far as the CAD goes, I didn't really change much on this. I did, however, probably the only real thing that I changed is to slightly modify the way that I was, that I had this groove in here, because we have up here the slip ring, as I've shown, like the big blue slip ring. The slip ring cables go down through this channel in here, and then we also have the yaw axis encoder down here, and its cables will also come out through this channel. And the way that I had this channel set up before was like very, very not printable. So I basically just cut out this big, like, what is that? Like a house kind of shape, and just like shoved that through, and then that printed completely fine. So it's not as elegant as before, and it's going to be potentially a little bit more fiddly to feed the cables through, because previously the channels were all like if I put a cable in through up the top, the only way that it can go is out, because the curvature of that channel would just force the cable to go out. But now, because there's this like steep right angle, it might get a bit more caught in there, but I think if I just get in there with tweezers, it won't be an issue. Yeah. So that printed perfectly. I'm super happy with that. One annoying thing is that you may have noticed before, the main ring, I ran out of red filament halfway through, and I swapped to black, and part of me really likes the way that this looks. Like, I think that what I would want to do is have like the two black strips on the side and then red in the middle. I think that could look really nice. However, I noticed just this morning that because these are different filaments, I'm going to guess this is the reason why. The red is PLA basic and the black is PLA matte, both from Bamboo. They actually, I'm definitely not going to be able to show this on camera, but they have ever so slight differences in, I guess it must be the extrusion amount or something, but there is like I'm definitely not going to show it on camera, but there's a noticeable increase in the like height of the black part. It's like where it's red, it's like a little bit lower, and then as soon as it steps onto the black, it's like, I can feel it, but it's not much. I wouldn't be able to measure that with my calipers. It's ever so slightly higher, and that probably won't be a problem. I really suspect it won't be, but like it's obviously not as good as having the whole thing be perfectly uniformly curved the whole way over. So while I do like the different colors, I don't know if I will commit to that. And I think for when I reprint this to get it to be all red, I think I'll just stick with all red. However, it is the fact that like the string is only going over onto this, like where this hole is. It's probably not very visible here on the red side, at least. You can see where that hole is, where the string comes out. I could make the black go up to where that hole is, and because that's never going to interact with the string, it doesn't matter that it's a little tiny bit thicker. So I might keep with the like red, black, red, but just have the red be quite thin. I think that could look cool. Yeah, but that's not really a big issue, and I'm not intending on reprinting that part until I need to. It just kind of irks me that it is like that way. Okay, so probably the biggest CAD change is to do with the hand actuator, and this probably comes as no surprise because that's the thing that I've been kind of working over for the last couple of weeks. And John had the great suggestion last week that I can massively, massively simplify what I was trying to do before. You may remember the really complicated pulley system that I had down the bottom here. That is all now completely gone, and we are just going with a much simpler setup where we have the O drive is mounted, like the hand O drive is mounted up above. We're going to be using the O drive S1 onboard encoder, so we don't need to mess around with any, like, there's going to be no noise problems. You don't have to worry about using like special encoder protocols or like communication protocols to get rid of noise. All of that's just gone. And now we're just, doing it the old school way. There's pretty much the same way that Juggerbot has it. However, this was not trivial to implement. Batboy says, a cool thing about the color is that it will have a visual left and right side, like the red-black color switch. Interesting. I think it will probably still have a pretty, like once it's actually built, it's going to have a pretty, like it's definitely not symmetric about like this mid-plane here. Yeah, I'm keen to play around with that actually. I think that the red, black, red could look quite nice. Yeah, so this wasn't super trivial to implement, and I started off by just going, okay, cool, this is easy. If we use the same routing technique that Jugglerbot has, where the string just goes, like, if we go to draw, the string just goes like up, around, down, around. Easy, done. We have 4 pulleys, we have the motor in the middle here, super easy, done, great. However, of course, it's not that simple. Because, and I did CAD all that up, I got it all done, and I was like, oh, this is so good, it's so easy now, this is so simple. But after a little bit of exploring the CAD model, I noticed that it is not that simple, because this pitch axis spool has to come through, and that has to be supported by something. And the way that I have that supported right now, at least, is with these 2 bearings in here. Which means that those, let me get rid of this stuff. Those bearings, if this string just went straight down from this top pulley up the top here, so that it can wrap around the motor, and then if it continued down, like being collinear with that, well, pretty much collinear with how it was before, it would have hit those pulleys, and that would not have worked. And I was very conflicted at this point between whether I should commit to having the O drive be above where it currently is right now, or if I could squeeze it in down in this bottom section down here. And I was very, very close to go with the bottom section, but I decided to keep it simple, just get this done, and then we can work on improving it later on. And that really kind of broke my aesthetic heart a little bit, but you know, it is what it is. And I do think this is kind of ugly and like a little bit, I'm curious to know what effect this will have of like having this weight all the way out. Because of course, like, we don't want the O drive to be like all the way at the top here, because then when the whole thing tips forward, that's really going to be trying to lift the whole thing up and like torque it over. So we definitely want this weight to be as low as possible, but it would be very tight to fit it into here with the design being the way that it currently is. So I decided to keep it simple and put it above. And an advantage of this is that with the way that I have fed this string through, so let me go on this section again. You can see the way that I fed this through now is up the top, we just have the standard 2 pulleys. We then go down to On the bottom, we have the standard 2 pulleys. However, so that the string doesn't interact with those 2 bearings that I just showed before, I have made it so that below the hand motor, the string goes basically inside the aluminium extrusion. It is like tucked in there, and that way we can still have these bearings here and they will not touch the string. That does require that we have a 5th bearing to kind of redirect the string back up to the hand motor, and that I'm pretty happy with this actually. I'm quite proud of this thought. I've put this bearing as close as I could possibly put it to the limiting parts, which are those 2. Whoops. So these 2 bearings are basically what we're trying to avoid, and as soon as we have avoided hitting them, then we can redirect and go straight back up to the hand spool. So that's why I've integrated that bearing as close as I could possibly do it to those 2 bearings, and then all that pulley to those bearings. And this way, as things are in the CAD here, I have the hand motor as close as possible to all of that stuff in there. And the reason why I've done that is just, as I said before, because if it's further up, then the whole thing will be trying to like torque over as it tips down. But I'm very aware of the fact that we do need a minimum distance between like this pulley and this spool, because as the string spools and unspools, let's say we go like this, as this string spools and unspools, that angle in here is going to be getting larger and larger. Now, there is a maximum angle that it will reach, and it's probably pretty close to what I've just drawn here. And to be honest, just like drawing this out, it does seem like the string will probably not come off of the pulley, but it might. And if it does, then because of the way that this is set up right now, this should be very easy to fix, because all I need to do is loosen these 2 screws in here and the same 2 screws on the other side, and then I can slide the entire hand motor assembly up as far as I need to go until the angle between until this angle in here gets small enough. So imagine if the hand motor was like, let's do this and this. I do know some shortcuts. If the hand motor was like was up here, then the string would only need to make an angle that's like that steep. So this angle in here is going to be completely fine. So yeah, I'm pretty confident that whatever problems come up to do with like the string being too tight of an angle, I can just shift things around and it should allow for that to be fixed, basically. Yeah. Yeah. I don't know. I do wish it was that it didn't have to be this way and that the hand O drive could be down the bottom, but it is what it is. And this, I am like very, very confident that this will work. Yeah. One other thing actually that I'm quite happy with is that you may notice that the O drive S1, a big reason why I was using the O drive S1 over the O drive Pro is that we can use a brake resistor with the S1. And you may have noticed that you may not have spotted the brake resistor in the CAD so far, but it's here. It's just hidden. It's tucked away in here. How good is that? So I wanted to have the brake resistor as like out of the way as I could possibly have it. And also it would be a good advantage if I was able to dissipate the heat from it out away from the brake resistor. Now I'm not expecting this resistor to get hot. I'm not anticipating having like a super high throughput of like throwing balls out, but it might get a bit warm. And given that all of these parts that I've printed are all in PLA, which is like the worst for thermal properties, I figured it's probably not a bad idea, and just in general as well, it's probably not a bad idea to have that. If I could have the brake resistor touching the aluminium extrusion, then I could put some thermal paste between them, and that way, as soon as the brake resistor gets a bit warm, all of that heat is just going to go straight out into this like very large aluminium extrusion. Yeah, so that is very well nestled in there, and I actually do have that as well, and that fits in like a glove. It's so nice. It's honestly like quite tight. I did have to, you can kind of see in there, I'll show you my dirty secrets. I did have to cut away at it a little bit, because what I didn't account for is that in my original CAD of the brake resistor, I didn't include all of these little fins in it. I only had like the rough shape, and my rough shape was like the smaller end of what those fins stick out to. So it didn't quite fit in the whole way, but with a little bit of trimming, it fits in perfectly. And I'm very happy with this. And to get those cables out of there, because of course, with this as it is, like it's like, okay, cool, the brake resistor's there, but we somehow have to connect this terminal to one of these first two, and this other one also to one of those first two. It doesn't matter which one's which, but they both have to connect into these first two terminals on... Oh. They both have to connect onto these first two terminals of the S1 over here. And to get that to work, let's go to a translucent view. Maybe if I hide some stuff, we can see that... Let's hide all this. Getting in the way. On this side over here, where this is like the outlet of the brake resistor, I have a channel that goes up through here. So like I can basically solder on a cable that's like perpendicular to the two brake resistor terminals. One of those will go just straight up, and that outputs right here, which is like a very good spot to go straight into that terminal there. And then the other one is only visible with the translucent view. It goes up, hopefully you can see it. It goes up through here, and then up through the second hole. So that goes up, out through this guy. And that way both of those cables will be very nice, very tucked away, out of sight, out of mind, and they'll go neatly straight into their two terminals where they need to go. So I'm quite happy with this. I think that will work very nicely. Yeah. Yeah, cool. So I believe those are the most of the updates on the CAD. Let's have a look through. Yeah. My silly mistake was that the pitch support arm was not centered, but that's fine. Yes, cool. So those are most of the updates. It did take a while to get to this point. I did have a lot of alternate options that I had in mind for a lot of these steps. I was really very strongly debating doing what I mentioned last week, where I was wanting to, I think the week before as well, actually, wanting to cut off the main ring and just like get rid of all of this, and it would be such a like futuristic, like cool design. But again, minimum viable product. I just want to get it to work. So I did not go down that path after a lot of deliberation. But yes, the only thing that I haven't changed or like updated is something that I was definitely kind of blowing it off as being something that would be pretty easy to do. But after a bit more thought, I actually don't think it's going to be as easy as I was planning on it being, which is the story of my life, you know? And that thing is the hand. And you can see the hand that I've got in here right now is not, it's not it. Yeah. So the problem is that we want the hand to be able to hold the ball at a very low angle in here. And what I was planning on doing, and I mentioned this last week, is to have like a scoop kind of hand. Very similar to what I have here, but just like the correct size. However, I'm not sure anymore that that is the way to go. Unless I come up with a better solution, or if someone suggests a better solution, I will probably go with, I will probably go with this exact design, but I'll scale it to be the correct shape. And then I can print that off like tonight and give it a go over the weekend. However, I'm a bit skeptical that this will work. And a big reason for that is because I really don't want the ball to ever roll as it's being thrown. If, I'm imagining with the scoop design, if we have a scoop, I wish I could do this, but like up here. If we have a scoop that's like this, say, and it's like resting like this, and then when we throw, if the ball ever wants to roll as it's being launched out, that's going to cause problems because these balls are filled with some kind of sand or something. And this massively helps them being caught. These are like the best balls for Jugglebot that I have come across. And I am not going to be changing these on Ball Butler's behalf. So yeah, and because they're filled with sand, they roll very, very weirdly. And as soon as they start to get any of this kind of like rotation momentum going, then the throw becomes very weird. And I've noticed that when I'm juggling these, they just feel a bit weird compared to normal balls. And I'm almost certain that the reason for that is because usually when I'm juggling, when I throw a ball, I kind of roll it off my fingers, and that allows me to really propel the ball a lot further than if I was throwing with my forearm. Like there's a lot of like finger action in throwing balls really high. And because the balls spin, I know that my balls, when I'm juggling normally, the balls spin like crazy when I'm throwing like quite high. When these spin, they just like wobble in the air, and it's very odd. And yeah, so we really don't want the balls to roll as they get shot out. And I'm maybe unnecessarily so, but I am a little bit worried that having a scoop kind of hand will encourage the ball to roll as it's being shot out rather than just kind of like sliding out. So I don't love the scoop idea, but it's the best thing that I can think of right now. I have considered as well, because when the ball is in the hand, like when the ball is about to be thrown, it is at the biggest risk of being dropped at low angles when it's in this lowest position. So I'm thinking like if we do need to make a throw at a very low angle, then one thing that we could do is bring the ball, like have this up, pitch axis up, bring the hand all the way down to the bottom while the pitch axis is up. Yes, exactly what David's thinking. Proper acceleration may seat the ball. Yes. I was thinking of taking advantage of that by lowering the hand all the way down and then coming down to the low angle, and we could have something attached onto the lid on here, just like a little pedestal for the ball just to rest on, and then as soon as the hand started to throw, because the hand is accelerating so fast, the ball is just going to be like held into the hand until the hand stops moving, and then the ball will go off. I'm a little bit worried about just relying on the acceleration. Like if we were doing that kind of structure that I just described, we could even use a hand similar to the one that I was using ages ago, which is like extremely shallow. And this can hold up to like that steep, which is pretty steep. This is another thing as well. So because the balls are filled with this sand, and maybe you can see it, no, the light's gone the wrong way. Because it's filled with the sand, it changes the way that the center of gravity sits. So you can kind of like get a bit more steepness out of the hold than you would be able to with another type of ball. But, of course, if the sand shifts the other way, then that goes against your favor. Like here, this is going to tip super early because I shook the sand to be like on the other side. So, I don't know, yeah, pros and cons. Batboy says, I would be a little worried about rolling, but I don't think it will cause too many problems. You're probably right. And yeah, because of course we haven't tested any of this, I don't know how big of an effect this will... Like, I don't know how much a scoop hand will encourage the ball to roll, and I don't even know how... And I don't know how much that amount of roll would affect the flight of the ball. I suspect both of those things will be fairly minor. Like, the friction between the ball and the plastic hand is going to be pretty low. However, for Jugglebot's balls, these are all covered in the retroreflective tape, and that tape, because you can't wrap a sphere in tape without it having little wrinkles, the tape has wrinkles in it. And those little wrinkles might get caught up in the plastic, and that could cause a bit more drag. Maybe. Yes, Batboy says, try printing off 2 or 3 and see what happens. Yeah, honestly, ultimately, I really like the idea of having like an open challenge for people to submit ideas for things. And I think that the hand is an area where we can do that, but I don't know... I think that the best way to do that will be on Jugglebot's hand in the future when Jugglebot can actually juggle, and it will be like, we can put a new hand on, try it, see how well it can actually juggle, and like once it's at the point where we can actually have like multiple throws going back and forth, we can say, this hand did 10 throws, this hand did 200, rather than like, this hand can catch, this hand cannot catch. You know, it's a bit more of a nuanced scale rather than just like a binary can or can't. So I really like the idea of like trying lots of different options, and I definitely think that the hand, whatever we do now, I am certain that it will be different in like 2 years' time, just because this seems like something that can be very finely optimized. And as well, a big thing to keep in mind as well with Ball Butler's hand is that Ball Butler will never need to catch, so it doesn't need the big like kind of cone shape that the Jugglebot needs, because Ball Butler will never need to be receiving a ball into the hand. So we could even potentially have just like 3 points of contact, and then as long as those are in the right spot, if that can hold it on that steep angle, then that should be fine to throw. We really don't need this whole thing the way that it currently is. However, even with that in mind, I can't think of a way to do this so that it can support such a low angle. Yeah, it's tricky. David asks, how fast can it accelerate? For short throws, it could do a short, abrupt throw. Yeah, it's been a little while since I've looked at the profile in too much detail. However, this that I showed off last week might have it. All right, so yeah, this kind of answers the question. This is not for... I actually don't remember what I generated this profile for, like what the parameters were. However, this will be very similar to a throw from Ball Butler. This length is the same as Ball Butler's stroke, so that is the same. But I don't know what the throw height is. I mean, it's like 2 and a bit meters per second, which if we quickly calculate, what is it? V squared is 2gh, so h is v squared on 2g. So we have, what is that, like 2.2-ish? 2.2 squared on 2 times 9.81. Okay, so this is a 25 centimeter high throw. So we might be throwing a little bit higher than this, and it can definitely throw higher than this. And unfortunately, I don't actually know what the unit on here is, but if we take the rise over the run of the velocity, you can figure out the acceleration. So what is that? 2.2 meters per second in about 0.15 seconds. So if I get my calculator out again, we have 2.2 meters per second in 0.15 seconds is about 15 meters per second. Yeah, and I believe from memory we can get up to like, we can get much faster than that. Like Jugglebot can throw to like 1.5 meters high from memory. So yeah, we can get pretty fast. I think it was like 20 or 30 G. No, 20 or 30 meters per second squared. Yeah, not 20 or 30 G. Yeah. It's confusing because like all of these things are in different units. Like the O drives take revolutions per second rather than meters per second. So I always get confused between like what unit is what. Yeah, Batboy says, I might try to make a scoop this weekend for you to look at. Nice. Yeah, please do. Yeah, I'm keen to see. Yeah, and as you say, these hands do print very quickly. So I am very open to trying a whole bunch out and just seeing what works. So yeah, if anyone else wants to give it a go, then please do. And yeah, I am not at all locked in on any specific design. I do strongly recommend as well having making a copy of this Onshape document, and then you can make sure that everything else fits nicely as well. Like I'm just noticing now that in this super low angle, the ball actually might contact the lid. So we actually might need to have a little bit of offset so that the hand is like raised up in like this direction. So like the center, so the ball will sit like here instead of where it currently is. So it might be a little bit offset in that direction. Yeah. I am also thinking potentially what I might end up doing, and what I probably will end up doing, is that for now, I won't make use of that super low angle. Like we can just have an artificial low limit of like 60 degrees or something, rather than 80. So that's a very strong possibility. And there's different ways to frame this, I think, but one way is that I am, in an effort to get this to work by next week, because next week will be the last stream probably for this year, which I feel very conflicted about, but it is what it is. I think what I'm going to work towards for next week, and it's going to be tight, but I think it might be possible. As long as nothing goes wrong, I think this will be possible, to have it so the ball butler can sit on my desk and then throw to me. So I will have the catching cone. This guy that you may remember from months ago, where Jogglebot was throwing balls. It's like I could like move this around into the room wherever I wanted, and Jogglebot can throw into here. What I'm planning on doing is having Ball Butler sit on the desk here, and then I can move around the room with this, and then Ball Butler can throw into this. And as far as I'm concerned, that's like 95% of the way to getting it to throw to Jogglebot, because that means that it can throw to a specific spot. I don't know how I'll check the time, but I'm a little bit more relaxed on that for now, especially while Jugglebot's like not actually juggling multiple balls. Like the timing aspect doesn't really matter as much. But the position aspect we'll be able to check that. And yeah, I'll call that a success. I think that'll be quite good. But that means that we won't really need to go to the super low angle. So because it will be throwing to me and I can move my desk to whatever height I want, we can make use of like the top like 70 or so degrees. So we can basically like keep the pitch axis like up in like these kind of ranges, which honestly probably would be fine for this little tiny hand that I have already. Yeah. Yeah. One other consideration as well for anyone who's keen to try to make a hand design is I want to try to keep it as light as possible. And that is a big, that kind of like works together with the fact that because this hand doesn't need to catch, we can make it as small as, we can make it very small. We only really need those 3 points of contact, and that's all we would need to support the ball and keep it in place while we throw. And that would be fairly easy to make lighter. Like if we don't need to worry about all of the other like scoop part of the hand, we can just have like a ring or just those 3 points and make it very, very light. Because the lighter that it is, the faster we'll be able to accelerate and the faster the ball will come out. Yeah. Yeah. Okay, cool. One other thing that's probably worth mentioning, because someone mentioned this in the comments to the last stream, is that to get the ball to throw higher, we want to make sure that if we're having problems with throwing the ball high, then one way to solve that is to make the spool that the string wraps around a larger diameter, because then for every revolution of the motor, the hand will slide further and we can actually throw it further and faster. And this has changed since last week. So last week I was using an 8mm diameter spool, and we were seeing I was showing the throw results in the videos that I recorded from last week. And that works, and even with that diameter, I feel pretty confident that this will work fine. However, because this current setup in here with we're using the onboard encoder and we've got the motor mounted the way that it is, we're actually able to use the same spool that Jugglebot uses, which is a nominal 9.75mm diameter. And I actually have one around here, but my desk is a bit of a mess right now, so I don't know where it is. But that's actually made of aluminium. So that is a very solid piece. And because it's a larger diameter than last week, we'll be able to throw faster than we were last week. And also because it's not 3D printed, it'll be a very solid connection. So we won't have the problem that I showed last week where they became disengaged. Yeah. So all in all, I haven't felt more confident about Ball Butler than I do right now. But it has definitely come at the cost of the aesthetics of the design, which is kind of, I don't know. I don't love it, but you got to do what you got to do. Yeah. Yeah. Okay. I think that's it. I said this will be a quick stream. Yeah. So if anyone is keen to work on a low angle hand, we want to have no rolling and a minimum launch angle of around 10 degrees. So that is with the hand as low as it can go. This axis that this is moving along is around 10 degrees off the horizontal. David says, huge progress. Thank you, David. And aesthetics are premature optimization sometimes. Yeah, it's just tricky because for a lot of these things, like you can really convince yourself, it's like, oh yeah, this thing is fairly simple and it will work because why wouldn't it? So because I don't want to have to like redesign again and again, I'll just make it the final way the first time, and I'll save myself all of that effort that I would have had to do if I made it ugly but functional and then had to make it pretty again afterwards. It's so easy to convince yourself that that is the sensible way to go, but you're definitely right. Aesthetics are, I would perhaps even say often, a premature optimization. Yeah. But the fact that it's not always, maybe it is always premature. Because if it's not always, then it's like, what do you do with that? Yeah. Anyway. Oh, actually, there is one other thing that I wanted to see people's opinions on, because I'm a bit conflicted about it. I'm debating whether I should include a separate emergency stop button for Ball Butler. So I'm already thinking, I really like, I don't remember who suggested this last week, so I apologize, but I do like your idea, to have the foam on the wall, so that way when, Ball Butler's on the shelf up here, it's obviously not going to be angled this way. I need to update the mates, but it works. If I unfix this. Of course, there is a wall behind the shelf here, and this can spin around and just like smack into the wall, and that's going to be a problem. And someone suggested last week that I can have a piece of foam against the wall, which I really like up there on the wall. I think that's a great idea. However, I think it might be possible that problems will, I guess, I don't know, when I verbalize this, it seems clear that I should do this. But it seems like if it is possible that Ball Butler will run into problems and it will kind of go haywire, that I will want to shut it off. I can do that. I do have an e-stop that will go straight to the power supply that is shared between Ball Butler and Jogglebot, but that will turn off both robots. Maybe there'll be situations where I don't want to turn off Jogglebot, but I do want to turn off Ball Butler. So I'm thinking I could put kind of where the yellow clamp is on the shelf over there. I can put a separate emergency stop for the power that's just going straight up to Ball Butler. So that way, if I hit the like global e-stop, it will turn off both of the robots. But then if I run over there and hit the e-stop that will be mounted on the side of the shelf, then I can turn off just Ball Butler. And I'm debating whether to do that, partially because these e-stops that I have don't come with like a housing, and I'll have to design a housing to go around this. And like, it's not hard to do, but it's something else that I would have to do. And like wiring it all up, like it is more effort. Including this is more effort than not including it. So I don't know. I did actually have this out a couple weeks ago, and I was going to mention it, but I just forgot to. And then after that, I was like, nah, I don't need the e-stop. Like, it's fine. I've just got the global one. I can just turn both robots off. It's fine. And I put this away. But I realized that, I don't know, it's probably worth opening this up and seeing if you guys have any thoughts on it. At the moment, I'm going to lean towards not including it and just having the global e-stop where I can just turn off both robots. But yeah, some part of me is like, this is a bad idea, and something will happen where, like, because there are situations where if Juggernaut's in a certain position, and if I turn the power off, it can collapse and fall into a bad state. Like, if it's all extended and it's all in some wacky position, and then it loses power, because the platform section is so heavy, the legs will collapse, and it has before fallen into very awkward positions, and I've had to like run over and like catch it and stop it from probably breaking. I should probably do it. We'll see how we go. Batboy says, I think while you're working on mainly Ball Butler, you should have a standalone e-stop, but might not want to have it while working on both. Yeah, I think while I'm working on just Ball Butler, I just won't plug in Jogglebot, so it just won't be getting power while I'm only doing Ball Butler. But while both of them are in use, yeah, it's probably not a bad idea. He said, I don't know, I changed my mind. I'm unsure. So am I. Yep. I think what will probably end up happening is, like, realistically, including this in the system is not going to be that much effort. It just feels like a lot of effort now because I've got so much other stuff going on. But I think if I leave it for now and then just only power Ball Butler, like don't plug in Jogglebot while I'm only working on Ball Butler, get Ball Butler working so that I can like pretend to be Jogglebot with the catching cone, and like I can be in the spot where Jogglebot will be. And then once I'm confident that Ball Butler's working perfectly fine, including this in won't be that much effort. It'll be like an afternoon of CAD and wiring, and that won't be too bad. Yeah. Okay, I think that's a good plan. And part of it's good because I don't need to do anything about it right now. Those are the best plans. All right, cool. Let's stick under the 1 hour mark for today. My mission for the day is to try to move all of the electronics and everything that are currently in here and basically build the new Ball Butler. And yeah, I'm keen for that. It's about time. It needs to be done. It needs to be built. And then we've just got software. And as we all know, I am amazing at software, and it's just going to work, and it's going to be easy. So next week, get ready for demos, hopefully. Livestream 69, last stream of the year. Let's go. All right, that's enough rambling. Cool. I hope you found this interesting. As always, any feedback, I love it. It's great. Please keep it coming. And yeah, if anyone wants to have a go at designing the hand, then by all means, I will continue with it as well myself. If I have time tonight, I'm planning to change this scoop design just so that it fits, and then I'll just print that off and hopefully it works. We'll see. I'm just trying to keep it simple. Yeah. But if you want to give it a go, then definitely by all means. As I said, I'd strongly recommend making a copy of this CAD, and that way you can make sure that it like fits in with everything else. And you can explore the rest of the CAD as well. You can see how I've done things. Some things are a bit sketchy, I will admit. I have not followed best CAD practices throughout this model, but I have tried to as much as possible. So, I don't know. You can judge me as much as you want, I guess. All right. Yep. Good luck with everything you are doing until next week. And yeah, I'll see you then.